This will be for the Khan Academy exercise justification with the intermediate value theorem. So you want to remember that the intermediate value theorem has two conditions. The function h is continuous over the interval a comma b. These are the x coordinates. The value d lies between h of a and h of b. Okay, these are the y coordinates. So in their write up, they're saying there's a value c in the interval a comma b for which a of c equals d. So they're just saying that point c is the x coordinate and d is the y coordinate. Okay, this should make more sense when we get to the exercise problems. All right, it says the table gives selected values of the continuous function g. All right, that's important that the function is continuous. Here's the table, the x coordinates and the y coordinates. Below is Min's attempt to write a formal justification for the fact that the equation g of x equals negative 50 has a solution where x is between 12 and 21. All right, before we looked at his justification, let's see if this is even possible. So the x values for the point in question, the x value is between 12 and 21. Here are the x values. So we know that it's going to be in between 12 and 21. So that part is okay. And remember, g of x is basically the y coordinates. Okay, so it says g of x is negative 50. We're dealing with the x coordinates of 12 and 21. And we're looking at a y coordinate of negative 50. Does that fall in this range here? Well, yes, between negative 10 and negative 100, negative 50 is definitely somewhere in between those values. Okay, so we didn't read his justification yet, but we know that it's definitely possible as long as he gets it right. So remember, you have to first mention that the function is actually continuous. All right, let's scroll down and see what he said. All right, so here's his justification. G of 12 is negative 10, G of 21 is negative 100, which means negative 50 is going to be in between G of 12 and G of 21. All right, that's true, but it says, according to the theorem, g of x equals negative 50 must have a solution at some point between x equals 12 and x equals 21. That part is true. However, he forgot to mention that the function has to be continuous. All right, remember that was the first rule, that it has to be continuous. The second rule is that it falls between the two x coordinates and the two y coordinates. He did mention that part, but he didn't mention that it was continuous. So that's the only flaw in his justification. All right, Min should have mentioned that g is continuous. So that was the only issue. All right, f of x equals x times 3 to the x. Can we use the theorem to say that f of x equals 100 has a solution where x is between 2 and 4? Okay, and again, it has the continuous, or if the function is between, or if it's a yes. So let's see. First, let's establish, is the function continuous? Well, if you think about it, there is nothing that you cannot plug in for x. Okay, right here, x can be 0, positive, or negative. Right here for the exponent, x can be 0, positive, or negative. So that part is okay. It's definitely continuous. All right, and we want to see if f of x equals 100 is going to be between x equals 2 to 4. Well, first let's see if we do the endpoints here, f of 2, because x is going from 2 to 4. If we do f of 2, that's going to be 2 times 3 squared. All right, I just subbed in 2 in place of x. 2 times 3 squared is going to be 2 times 9, which is 18. And now let's try f of 4. That's going to be 4 times 3 to the 4th. All right, and that's going to be 4 times 81. And that's going to be 324. So is it possible that f of x equals 100 is going to be between x equals 2 and 4? Yes, 100 is definitely in between 18 and 324. So that is entirely possible. Okay, and the function is definitely continuous because, like we said at the beginning, there's no value that x can't be, especially between 2 and 4. You can plug in any number for x in between 2 and 4, so it's definitely continuous. There's not going to be anything that's undefined. Okay, so I'm going to say it's a yes. All right, just to be clear, this f of x equals 100. This is a y coordinate. Okay, in order to get the y coordinates between 2 and 4, I had to plug in 2 and 4 into this function here. These are also y coordinates, okay? So anywhere from 18 to 324 would work for this value here. All right, so it's a yes. All right, the table gives selected values of the continuous function f. That's important, that it's continuous. Here are the values. And can we use the theorem to say that f of x equals 150 has a solution where x is between 0 and 5? Okay, here are the x values. This is 0 and 5 right here. This is the interval. We established that it's continuous. Does 150 fall in this? This is the y coordinate, all right? These are the y coordinates right here. Does 150 fall into this range right here for the x of 0 and 5? No. You cannot take 150 and say that it's in between 175 and 230. That does not work. Okay? So it's not in between. That's the problem right there. Okay, the continuous part is good, but 150 is not in between these two numbers. So it's going to be a no. But choose the correct no, as you will see. All right, 150 is not between f of 0 and f of 5. All right, last one. F of x equals the third root of cosine of pi times x. Below is Isaac's attempt to write a justification for the fact that the equation f of x is 0.1 has a solution where x is between 1.5 and 2. First off, let's see if that's even possible. Okay, right here we have a third root. That's an odd root, okay? So this could be anything. This could be positive or negative because it's the third root. If it was a square root, we wouldn't allow negatives. It would only have to be positive or 0. But third root is okay. Cosine, you can enter any value in here for cosine, you'll be okay. So it's definitely continuous. All right, we got that part out of the way. Now, we want to see if it's possible that f of x equals 0.1 is between the x values of 1.5 and positive 2. All right, so we're going to have to evaluate the function at those values. All right, so f of 1.5 is going to be the third root of the cosine. And we're plugging in 1.5, so it's 1.5 pi. All right, let me go to my calculator, make sure it's set to radians. Okay, and I get 0. And we also have to try it for 2. So I'm going to do f of 2. And that's going to be the third root of the cosine of pi times 2, or 2 pi. I don't even need the calculator for that one, because on the unit circle, you start right here at 0, you go counterclockwise. 2 pi is basically once around, so that's this point right here. Cosine is the x-coordinate, okay? The x-coordinate right here is a 1. So this is going to be the third root of 1, which is just 1. Now, these are the y-coordinates, 0 and 1. All right, so the y-coordinate, f of x equals 0.1. That is definitely in between 0 and 1. All right, so let's scroll down and read his justification. All right, so he does mention, he solves for f of 1.5 and f of 2, and he says that 0.1 is in between those two values. So that part is correct. And then he concludes that it must have a solution. Okay, that part is correct, but he forgot to mention that it's continuous. Okay, that's really the first step, that it has to be continuous. So that's the only issue here. All right, he did not establish that it's continuous. All right, if they give you the function tan of x, you want to remember that tan of x equals the sine of x divided by the cosine of x. And we know that you cannot divide by 0. So where is cosine of x equal to 0? Well, on the unit circle, the cosine is the x-coordinate. And right here, the x-coordinate is going to be 0. Right here, this angle is basically pi over 2. Okay, and the x-coordinate right here is 0. You can't divide by 0. So in this case, x cannot equal pi over 2. And if you keep going around the unit circle, okay, when you come to this point here, the x-coordinate again is going to be 0. This is going to be at 3 pi over 2. So x cannot equal 3 pi over 2 either. Okay, and that's for the tan of x. If you have any issues as far as like, if you don't know if it's undefined or not, then just go to Desmos and graph it. So let's do that real quick. We're going to graph the tan of x on Desmos. All right, actually, I just Googled graph of y equals tan of x. Okay, and you can see right here, here's x equals 0, here's pi over 2. There's an asymptote at pi over 2. So the graph of tan of x will never reach pi over 2. It's undefined there. And also 3 pi over 2. There's an asymptote right there. So it's undefined there as well. So you can either use Desmos or Google, whichever graph you need, to see where it's continuous and where it's not. If there's an asymptote here, it's not continuous. And right here as well. This is actually infinite discontinuity because these are vertical asymptotes.